Hello everyone, my name is Mr. Yoon and welcome to my Math 12 video channel. I created these videos to help students understand the concepts that are being taught in class, so feel free to watch these videos at your convenience. For my very first video, I'll be covering the graphing chapter, and for the very first lesson, I'll be looking at horizontal and vertical translations. Alright, so let's start today's first lesson. So the topic for today's lesson is translations and functions. So the very first thing that we need to do is we need to understand what the word translation means for Math 12. So let's take a look. Translations. Translations, graphically, this is when you are moving an object without rotating or changing its shape. And for translations, we have two types. We have a vertical translation. So vertical translation basically means the object is moving up or down. And if you take a look at my diagram right here, you'll notice that this green object is moving up or down, which represents a vertical translation. And notice that when this object is moving, we're not actually rotating or changing its shape. It's just simply moving up or down, which represents a vertical translation. The other kind of translation that we'll look at for today's lesson is called a horizontal translation. And a horizontal translation simply means that when you have an object, your object will move to the left or to the right. Once again, when you see this object moving to the left and the right, you'll notice that the object is not rotating or changing its shape. It's simply sliding from one section to the next. All right, so those are translations. I want to look at horizontal translations now, and when I talk about horizontal translations, sometimes I'll use the letters HT for short. So a horizontal translation occurs when the x variable is changed by adding or subtracting a constant. All right. Now, horizontal and x variable. So whenever you see the word horizontal translation, you should be thinking about changing your x values. Where are the x values? Well, the x values are the horizontal numbers on your grid. So horizontal will always change your horizontal and your x variables are connected. And a constant, just a reminder, a constant is, for example, like 1, 2, 3, -5, -8, or maybe 3.14. A constant is simply just a number. Let's take a look at y equals to x squared. Now, y equals to x squared, this is a parabola. You studied parabolas in Math 11. And when you're looking at translations, often what you want to do is you want to focus on the x variable. If the x variable is being changed, then that probably means you're dealing with a horizontal translation. So what you want to do is sometimes you want to draw a circle around the x only, and you want to ignore everything else. That means you want to ignore the exponents, squares, and radicals. So for this example here, notice that I have a square there. You just want to forget about that right now and just focus on the letter x. All right, so when we have y equals to x minus 3 squared, notice that my x has been changed from x to x minus 3. Okay, so since the x variable is being changed, that is a horizontal translation. Let's graph y equals to x squared, and then we'll graph y equals to x minus 3 squared, and we'll see what kind of translation happened. Now, when you want to graph anything in math, and if you're not sure what to do, you can always make yourself a table of values. For a table of values, you have your x and y variables. This is your independent variable, and this is your dependent variable. So you are always responsible for finding your independent values. So you need to find the x values, and then you need to compute the y values from your x values. For example, I will just randomly pick these numbers for x, 0, 1, 2, 3, and -1. So these are the numbers that I have picked. And based on these numbers, I must now calculate the corresponding y values. So if I take this 0 and plug that in for x, 0 squared, that would mean y would be 0. All right, so let's just fill in this table here. If I look at this number 3 here, if I plug in 3 for x, 3 squared will give me 9. All right, so let's plot those points now. And there you go, y equals to x squared is simply a parabola. It opens up, the domain is all real numbers, and the range is y is greater or equal to 0. Because this graph is everything above everything above 0. All right, now let's look at the graph y equals to x minus 3 squared. Let's take a look at it, and let's just see what this graph looks like. So once again, if I'm not sure what this graph looks like, I can construct a table of values. So let's do that. Those are my x values that I picked randomly, and then I can find the corresponding y values. And when I graph those points, this is what the graph of y equals to x minus 3 squared will look like. All right. So what do you notice about these two graphs? What do you notice about this graph? And what do you notice about this graph right here, the new graph? Well, one thing I noticed is that for the first graph, my vertex is at 0, 0. And for my new graph, my vertex is at the point 3, 0. So what I see is the graph has actually moved 1, 2, 3 units to the right. All right, so if I highlight my first graph, it's being moved 3 units to the right. So the idea is when you have an x, so this x represents this x right here. If that x is being changed to x minus 3, which is this x minus 3 right here, that means your graph is simply moving 3 units to the right. All right, let's take a look at another example. Given the following equations, y equals to x squared and y equals to x plus 4 squared, I want to graph both equations and indicate what translations occurred. All right, so let's take a look at the graph y equals to x squared. And this is the same graph from the previous example, so this is your basic parabola opening up. And let's take a look at y equals to x plus 4 squared. All right, so when you graph that, it's going to look something like that in blue. So what do you notice about the red graph and the blue graph? Well, for the red graph, my vertex is at 0, 0. And for my new graph, y equals to x plus 4 squared, my vertex is actually at the point negative 4, 0. All right, so what I see is my original graph right here, it actually moved. It's actually moving 4 units to the left. All right, so when I have a y equals to x plus 4, what that means is my original graph will move 4 units to the left. Okay, so when x is being changed to x plus 4, so here's my x, and x is being changed to x plus 4, that would indicate the graph is being shifted 4 units to the left. Right. Good. Now let's take a look at vertical translations. So when I'm talking about vertical translations, sometimes you'll see the word VT. So VT stands for vertical translation. A vertical translation occurs when the y variable is changed to a y variable adding or subtracting a constant. All right, so what does that mean? So for example, if I have y equals to x squared, if I circle the y variable only, if that y variable is being affected by another constant, then that means I have a vertical translation. All right, so take a look at this example here, y plus 3 equals to x squared. Notice that my y is being changed from y to y plus 3. So that is an example of a vertical translation because my x variable is not being changed. All right, and once again, when you think about the letter y represents your vertical values. All right, so vertical and y. And if you forget what a vertical translation is, just remember vertical means that you're talking about values in the y direction, positive or negative. All right, so if you have something like y plus 3 equals to x squared, sometimes you will also see this as y equals to x squared minus 3. We are simply taking the plus 3 and we're moving it over. So sometimes you might see your y being changed as y plus 3, or you might see it as y equals to x squared minus 3, but both of these expressions are actually the same thing. All right, so let's graph y equals to x squared, and then we're going to graph y equals to y plus 3 equals to x squared, and we're going to compare the two graphs. All right, so once again, this is exactly the same graph from the previous lessons. From the previous examples, y equals to x squared. So let's take a look at the graph again. Here is the parabola. And now let's look at our new graph, y equals to x squared minus 3. So this right here represents this equation right here. They're exactly the same. So let's take a look. Here are my x values that I picked by random. And when I plug in these x values, for example, if I have 0 right here, if I plug in 0, 0 squared minus 3, that would mean this value would be minus 3. All right. So here are my corresponding independent values, and here are my corresponding y values. Let's take these numbers and let's construct the graph of y equals to x squared minus 3. And there it is. So when I have the point 0 comma minus 3, that's actually this point right here. This point represents 0 comma minus 3. If I have the point 1 comma 1 minus 2, so this pair right here, this ordered pair 1 comma minus 2, that's this point right here. This is the point 1 comma minus 2. So what do you see? When I see the red parabola and when I see the blue parabola, I can see that the red parabola actually moved 3 units down. All right, so how can we summarize this? There it is. The red parabola has moved 3 units down. And if I want to summarize this, if I have y, here's my y, which is my original y there, and that's being changed from y to y plus 3, which is the y plus 3, that would indicate that my graph is being shifted 3 units down. All right, so if you have a y plus 3, you need to think about the opposite. So the opposite of plus is going down. Given the following equations, y equals to x squared and y minus 2 equals to x squared, let's take a look at this example here. I want to graph both equations and I want to indicate what translations occurred. All right, so we're definitely using y equals to x squared a lot in this lesson, which is good. So let's take a look here. There's my graph. There's my parabola, y equals to x squared. Now let's take a look at this y minus 2 equals to x squared function here. This function right here. So let's put up a grid. And once again, sometimes you might see y minus 2 equals to x squared, or you might see y equals to x squared plus 2. These two functions here, although they look different, they're exactly the same. So if you have a minus 2 here, and if you bring that to the other side of the equation, this is the equation right here. Sorry, this is the equal sign right here. If you bring the minus 2 across that, then we simply change the minus to a plus. There's my grid. And let's graph y equals to x squared plus 2. And when you compare these two graphs, you can probably tell that the red graph compared to the blue graph has moved up 2 spots. All right, so here's my original graph. And let's just move that 2 spots up, which represents y equals to x squared plus 2. So to summarize, if I have a y variable and that's being changed to y minus 2, the graph is being shifted up 2 units. All right, let's summarize all the things that we've kind of covered so far. A horizontal translation, what that means is you are changing the x variable. So if you have y equals to f of x, if your x variable is being changed from y equals to f of x to y equals to f of x plus or minus k, that represents a horizontal change. So for example, from x to x minus 3, this means you have a horizontal shift of 3 units to the right. Now, what you want to do is, if you see a minus sign here, basically how to solve these kind of problems, you gotta think about the opposite. Minus kind of means that you're going to the left, but in reality, for translations, it's the opposite. So a minus would mean that you're moving to the right. So if you have x being changed from x to x plus 3, if you have a plus sign there, that means you have a horizontal shift to the left. So if you have a positive sign here, what's the opposite of being positive? Well, that means you're going to the left. And for vertical translations, we are changing the y variable. So any changes in the y variable would represent a vertical translation. So here's my y. If I have a y plus or minus a k, which represents a constant, k could be, once again, like 1, 2, or 3, or 4. So whenever the y value is being changed by a constant, that represents a vertical translation. All right? So sometimes you'll see it like this, where y is being affected, and sometimes you might see the constant on the other side of the equation. But notice that the x variable is not being changed, all right? So that this indeed represents a vertical translation. So please don't get that mixed up. So here's some final examples here. If I have y minus 3, once again, if you see a negative sign, that does not mean you're moving down, but it actually means that you're actually moving up 3 units. And one last example, if I have a y changing from y to y plus 3, I have a positive. That doesn't mean I'm moving up 3 units, but it actually means the opposite of that, which means I'm moving 3 units down. All right, so those are the concepts of this lesson. Now let's take a look at a few more examples to finish the lesson. All right, so here are a few more practice questions. The idea is I want to indicate the translation for each of the following equations. So for question A, I have y equals the square root of x, and that's being changed from the square root of x to the square root of x plus 3. So what kind of translation does that represent? Well, here's my x variable, and I notice that my x variable is being changed from x to x plus 3. So since x is being affected, that means that this is a horizontal translation. And since I have a plus 3 there, what's the opposite of plus? The opposite of plus means that we're actually moving to the left. All right, so once again, x is being changed from x to x plus 3, which represents a horizontal translation. And I'm simply moving 3 units to the left. And what about b? So for b, once again, you'll see that my x variable is being changed. So this represents a horizontal translation. X is changing from x to x minus 4, so this means I'm moving 4 units to the right. Good. And for c, you'll notice that when I circle my x variable, you'll notice that the x variable is not changing. All right, so I'm not dealing with a horizontal translation this time. In fact, what I see here is I see a negative 5, and if I bring the negative 5 over to the other side, when you bring a negative to the other side, it becomes positive. And when that happens, I see that my x values are not being changed, but in fact my y values are being changed. So y is changing from y to y plus 5. All right, so once again, y is being changed from y to y plus 5, and that represents a vertical shift of 5 units down. So once again, if you see a y plus 5, the opposite of a plus is actually going down. All right, so for option number D now, you'll notice that my x variable, is being affected. I'm going from x to an x plus 1, so that's simply going to represent a horizontal shift of 1 unit to the left. But then again, I also have a 3 here, and if I move the 3 to the other side, right now it's positive 3, if I move that positive 3 to the other side, it becomes negative 3. So now my y value has changed, my y variable has changed from y to y minus 3, and that will represent a vertical shift of 3 units up. Next example, indicate which of the following is the correct translation. So let's take a look. If I go from y equals to x plus 4 to y equals to x minus 5, what kind of translation happened? So I have 4 options. Let's graph both of these equations and let's compare them. All right, so here is y equals to x plus 4. So this graph right here, y equals x plus 4, is simply my blue line. And y equals to x minus 5, that is my red line right here. So when you take a look at these two graphs, what changes have happened? Well, if I look at this point right here, and if I look at that point right here, let's take a look. I mean, what happened here? I actually moved how many units down? All right, so I've actually moved roughly, if you count all the units, I've actually moved the blue graph actually 9 units down. So one of the translations that has occurred is a translation of 9 units down. Now you could also have another answer. Let's take a look. here is y equals to x plus 4, and here's the point y equals to x, sorry, this is y equals to x minus 5, and this is y equals to x plus 4. If you take this point right here, and if you compare it to that, to this point over there, you'll notice that the blue line has moved actually 9 units to the right. So for this question, there's actually two answers. If you have your blue graph and your red graph, the blue graph could move 9 units down and still get the red graph, or you could take your blue graph and move it 9 units to the right and still get the same corresponding red graph. So when you go from y equals to x plus 4 to y equals to x minus 5, simply you're moving 9 units down or 9 units to the right. All right, let's take a look at the final example for today's lesson. Given that the coordinates a, b is on the graph of y equals to f of x, indicate what coordinates will be on the graph of y equals to f of x minus 3 plus 2. All right, so I have y equals to f of x, and that's being changed from this into y equals to f of x minus 3 plus 2. And the point AB is located on the graph of y equals to f of x. So how will the points AB change when I apply these translations here? So my x is being changed from x to x minus 3. So clearly you can see that the x variable here is being changed from x to x minus 3, which represents this notation right here. So this means a horizontal translation of 3 units to the right. So if I'm going 3 units to the right, how do I change A to represent that? How do I make this 3 units to the right? Well, I simply just add 3 to the A, so A plus 3. This represents 3 units to the right. And finally, you can see that my y variable is going from y to y minus 2. So here's my y. And if you look at this whole equation here, this plus 2, if you take that to the other side, you'll notice that y will indeed change from y to y minus 2. So this would represent 2 units up. All right, so if y is being changed, I need to look at my b variable here, and how do I change that from how do I change that from y to y minus 2? Well, I just need to add 2 more units. So this will be b plus 2. And this will be my final answer, a plus 3, comma, b plus 2. All right, so that concludes the first lesson. If there were any problems, feel free to watch the video again, and we'll see you again for the next lesson.